Hello YouTube viewers, welcome to my channel S2T. In today's show, Science Thursday, we're gonna talk about anti-solar cells. So let's dive right into it. Now, this is kind of picked up very recently, and I'm reasonably sure in 2020 this was all the hype, and you must have heard at least one or two news sites like this anti-solar panel. So, what we are talking about? We are talking about something that works in the dark. Basically, it can work on inside something, or it can work in flat out darkness. It does not need light. It's not working on basically starlight or light from the galaxy or light from the moon. It's not working like that. It needs darkness to work. That is the interesting part. It needs darkness to work, and that is why it is specified as anti-solar. Now, and it's not like it's gonna just be there. It's gonna provide power, and I mean tangible amounts of power, not as much power as a normal solar farm, but comparable enough that it's something that people can consider as a nighttime replacement. Because right now solar technology is the only technology in green renewables that has a dollar per watt is actually close enough for coal technology. Like if coal gives you power per like basically let's say $1 per watt, solar is like $1 0.2 cents or something like that. So it's almost close, but problem is even then that's the scenario, and every country knows that sooner or later all their coal mines dries up. That they know this, and many companies, countries, mines have already suffered through this. Say they know solar is a long-term investment. Problem is what the hell you gonna do at night. Now if this puppy can provide even a sip of power, like let's say 10% power at night, that's a big relief. That reduces the demand on non-renewable sources, and or even in the battery banks. So it is a very big deal, and it also has no moving parts. So solar, you have to understand this, solar if done correctly, it is very like put it and forget it. Why? Because solar cells are inherently just a semiconductor bridge, and all it does is just converts photons. So it takes the energy from the photon and gives it into electron. So due to not having any inherent moving parts, it can last for a very long time, and things that break are generally the inverter and transmission systems, and those are quite easily replaced. So it's a very long term investment. So anything that must compete against it must also have that kind of longevity. So that is why this also has no moving part. You put it and forget it. So before any this kind of magical situations happen, and you must have seen there is so much bad scientific things going around, where it's like some science is true but they're mixing it with hoo-ha, and then people are like solar roadways and all that jazz. So before any of things like that happens, people generally have two steps of building something. You have science and you have engineering. Many times science are correct but engineering is impossible, then it's a BS. Or sometimes it's like science is meaningless, then it does not matter. So that is why you do not have free energy system. So this sounds like it, this sounds like there is a free energy coming out because it needs darkness to work. So how the heck it's extracting energy? So you have to understand the science of it, because energy has a simple rule to it: it cannot be created nor destroyed. So you must follow this rule. So what we are talking about is inherently how most engines work in this planet. Basically, be it jet engine, be it piston engine, be it diesel engine, be it steam engine, we are talking about a heat engine. Basically you take heat from one source, whatever that may be, and you dump it. Now you, while dumping it, basically heat going from high temperature to low temperature, you get the work out of it. And that is why no free energy system works, because where the heck you're getting the energy from? First, let's say you got it from somewhere, where the hell you're dumping it? Because that dumping cannot be 100% efficient. It can be close, but not no cigar, so to say. It cannot be 100%. So free energy, that's why it does not work. So in this scenario, we are talking about a heat engine. Basically it takes temperature difference from point A to point B and gets some works out of it. Now is that real? Is that normal? That's every single damn engine in the history of existence, that's what they do. And if you want something that does that without any moving parts, you have to look into Peltier thermoelectric devices. This can act as a cooler or it can act as a generator, and they have been used in satellites like Voyager and rovers like Mars rover. So you can understand this is time tested technology, and it works. So that's the whole point. You're gonna have a difference in temperature, and you're gonna basically extract work because of that temperature difference. So this puppy is not magically creating energy. It's like there's a temperature difference, I'm gonna extract energy out of it. So that's the science. So science is true. We are not talking about pseudoscience. Science is absolutely true here. So how the heck does this work? Well, you have to understand that Earth is very hot. Why it's hot? Because sun is heating it up. But you also have to understand that the Earth radiate heats out in this space. How the heck it can do that? Because space is colder. There is nothing in space that will absorb it and re-emit it back us other than the moon. So So you have earth, which is like this. It's like a ball floating in space, but space is absolutely low temperature, like it's as close to absolute zero as can go normally. So earth is hot and you have space which is cold, so you got two temperature difference. Then the question becomes, how the heck you gonna transmit, because there is a giant atmosphere in between, 100-kilometer thick atmosphere. Again, it's not thick at 100 kilometer, but you get the point, it's thick thing. So we have to find something interesting in that. Now our atmosphere, due to its gas composition, has what we classify as a window. You have to understand this when you see atmosphere through me. Now atmosphere has some things that it blocks, some things it lets through. So that is why infrared does not go through atmosphere very properly. That is why we need James Webb Telescope to be placed outside of Earth's atmosphere, because that specific infrared system be absorbed by the Earth's atmosphere. So you need something that allows you to transmit without affecting the atmosphere. How can you do that? Thankfully, due to gas composition of our atmosphere, there is a giant window. That window starts from 8 micrometers to 13 micrometers, nanometers. Basically, this is the infrared spectrum. If you take infrared spectrum, there is a giant spectrum, like it's huge. There is a slice, little slice here. Now this slice allows you to radiate heat, and that's how Earth dumps most of its heats away. So that spectrum, that bandwidth, if you can dump your heat in that, it's like atmosphere is not there. You must have seen many of the demos where they are showing like, infrared camera can see through plastic bag, but it can't see through glass. It's invert of that. It's like atmosphere is blocking everything else almost to 100%, but this spectrum can literally go through like there is no atmosphere. So that's our way to connecting that cold temperature, almost absolute zero of the vacuum of space, to heat source of Earth itself. That's how we are doing it. So we have temperature difference from vacuum of space to basically Earth, and it does not need to come from geocenter, or like, it's just Earth itself is hot, the atmosphere itself is hot, the buildings that heat up during the day, they are hot. So you have the heat source. Then you have the temperature difference between the hot surface to like minus 200 degree. So utilizing that heat difference, you're gonna run a heat engine, and that heat engine is gonna give you electricity. That's the engineering part of it. We knew the science, you need temperature difference. This is how we're getting the temperature difference, and this is how we are connecting them, because there is an atmosphere window that allows you to transmit. Okay, so that's the mathematics, that's the engineering. What about the reality? Now reality in mathematical sense, they know from a fact, like with all the maths and all that jazz, they know that it cannot compete against a solar cell, flat out no. So if I give you a like 1 square meter, you can expect upwards of 200 watts of power out of it. This puppy, best case scenario is 25. So that is why every place you will see they can talking about 25 watt per meter square. Now they built it. This is a real thing. This is somebody from the university actually sat down and actually built it, to run some test on it. So what was the power output? Then the power output, real power output, was around 25 milliwatt. So you're like, wait a minute, that's a bit too low. Again, that's the reality. Like when somebody talks about 25 watt per hour, that's a mathematical thing. So it's like somebody saying your car engine should give you 100 miles per gallon. It can theoretically do that, but it has to be like 96% efficient or even more. But in reality, it's 20% efficient. So that's the reality of it. So temper your expectation, because like it has been overhyped like crazy. Because if you could truly achieve that 25%, that means all solar farm will produce like minimum 25% of its power. That's a lot of power. That's like backbone level power. I mean, most people can do in this way, that like, hey, we have a solar farm that works 24/7, and during daytime it gives us most amount of energy. Amazing. Like we will forget about coal, like we'll forget about coal if that happens, but it's not so easy. So how the heck this contraption works? It's surprisingly simple, because I specified there is no moving part in this. So you have this metal disc. Now this metal disc is coated with a black paint. The sole reason for that, so it allows the infrared spectrum to be shifted. Basically it's like in black body emission radiation, you want that to be in that window. Basically if outside the window, it will reflect back, so you have to be in that window. So that black paint allows it to do that. And then you're gonna have heat from surrounding air, surrounding buildings, the rooftop where it's kept. It's gonna absorb the heat through aluminum heat sinks. Those heat sinks are connected to what we call thermoelectric generator. That generator is the cold side of the generator is connected to the radiator. So radiator is emitting thermal radiation in that window where it can go through. It can actually go through the atmosphere, not bounce back because of carbon dioxide. And during this temperature difference between cold radiator and the hot surroundings, you're gonna get energy out. Does this work? Absolutely. This was made using household products, and if you want it, you can build it in your home. Like this is something doable if you want it. Heck, if you're living in India, I'm reasonably sure I'm gonna get much more power out of this, simply because my building gets hot, and it gets as hot as 40 degrees Celsius. building itself, and the sun temperature can go to crazy amount. Let's not talk about that. So it can be done, and they are specifying that some places like deserts and all that, especially if the building heats up too much, this can act even more efficiently, because the higher the temperature gradient between the cold side and the hot side, the more effective it becomes. So reality is there, it can be done, physics is there, engineering is there, and we are starting to build it. But you have to understand, it's nowhere near, hey, can I order, like, 100 square meter of this anti-solar panel? No, it's not there yet. It's like far away, but the train has left the station. So what we can expect in the future? Now you have to understand this. There is a lot of room for improvement. Like 25 watt per like square meter. That's good. Like that's not amazing, but that's good. But going from that to like 0.25, yeah, that's tenfold. You need to improve the thing tenfold, and then you have to make it cheap. There are many technologies that are amazing, but the sole reason nobody uses that is too damn expensive. Like I'll give you a simple example. India in Delhi uses CNG. Now CNG is quite amazing because it's basically methane. But if we, let's say, all the public transport that is using CNG, instead of using combustion engine, they use fuel cell, hydrocarbon fuel cell, which works on methane, and it works effectively well. It's going to improve our mileage by twice at least, and the heat that is coming out of the fuel cells can directly run what we call absorption chiller, and you can get the cooling out. So Volvo buses, which are like air conditioned buses, India does get hot. So running that on the heat energy, running the motors on the electrical output, you're gonna get like much more higher total system efficiency. You are talking about around 60% efficient rather than 10-20% of the combustion system. Why don't we do it? It's too damn expensive. It will cost like 3 to 4 times the normal bus. So that's the reality of it. It must become cheap. Thankfully, inherently everything is cheap, and if once mass produced, even complicated things become cheap, same as your mobile phone did. So it can be done. Physics is there, engineering is there. However, there is one thing with this dude who came up with this idea, like the anti-solar panel, that was like oh, last concept, we might be able to do this also. But the main reason why he's so excited about it is he figured it out, like how the heck we're gonna dump heat without absorbing heat. The biggest problem with our buildings is, let's say you want to build something like this, you know what will happen if you did this? It's gonna heat up. Why does it heat up? Because sun heats it up. So they figured out a way to design a structure, a nano structure that reflects the sun's heat. So sun is dumping 100 watts of heat, it's like nope, it reflects almost 99% up. Now when you have fluid running in it, basically these are liquid channels, when you have fluid running, fluid is dumping heat into the system. Now this system is fine-tuned in such a way that it rejects heat in that spectrum, so it actually goes away. The heat actually goes away, it does not retains there, it actually cools down. So they have successfully managed to do this in the broad daylight while reducing the temperature of the fluid that is circulating without evaporation. Let that sink in. Without evaporation, because you can do that with evaporation, but you cannot utilize that in a desert. This completely sealed, you can do that. So that is amazing aspect of it. So this individual, and I have provided the TED talk, it's quite amazing. So if things can work out, if he finally figures out the mass production, the large scale commercial and all that, it can revolutionize the passive cooling industry. Basically everything requires cooling, all the buildings. Imagine all their rooftops are like this. It's just a simple thing, like it's just cooling normally and making sure it's not getting heated up at the same time. It's not just like a mirror, it's also acting as a radiator at the same time. Amazing things will happen. So, and he was also lost a small company that is acting selling these puppies as a booster to your refrigeration system, reducing electrical cost by around 10-12%. So it's something that is tangible, something that can be made, something has been made. So it's a lot of basically potential here. Now if done correctly, it can improve our world, because his main concern was that as our world heats up, we're gonna buy more and more air conditioner is gonna dump more heat into it, then we're gonna run even more air conditioner, and it becomes a closed loop system. We're gonna destroy ourselves. But if we utilize this, where we are like just rejecting sun's heat, it's like, bro, you shall not pass, and we're gonna dump our heat into vacuum space, broad daylight, and easily in the night, we're gonna do amazing things. That's the whole point of this. So I'm not that interested into anti-solar system. If it works out, if it truly achieves that 25 watt, which is very unlikely, because again 25 watt was sold to us and we got 0.25, there's a gap. But let's say he finally figures out how to mass produce those kind of panels. It is amazing, especially in India. This is amazing potential into this. So I am looking forward to this future. It's gonna be interesting at least. So this was my presentation on anti-solar technologies, basically anti-solar panel. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.